Get ready to unravel the cosmic mystery, folks. Dark matter and dark energy are like missing variables in an epic equation. Scientists are still trying to crack their codes. These enigmatic names are just placeholders until we've got a clearer picture of what's going on. Think of them as X and Y waiting for the right formula. Let's start with dark matter, the first piece of the puzzle that's been discovered. Here's the shocking truth: it is indeed matter, but not the kind you'd expect to find in your backyard. You've got the hang of it. Baryonic matter, the familiar stuff we know and love. It's the building blocks of everything around us: atoms, made up of even tinier subatomic particles like protons, neutrons, and electrons. This is what stars, planets, and galaxies are primarily composed of. But hold on to your seat, because that's not all there is. Dark matter, a separate entity, also takes up space and has gravity, but it doesn't share our baryonic roots. Dark matter, the mysterious unseen player in our universe. It's as if this phantom substance slipped right past us by not interacting with light. No emission, no absorption, it just quietly cruises through space. We might not be able to spot dark matter directly because it doesn't respond to electromagnetic energy. But its presence is felt, and we've got a detective story to tell you how. It turns out that dark matter's most telling clue is the gravitational force it exerts on visible objects, like stars, galaxies, even galaxy clusters. By observing these visible objects' movements, we get a hint about what unseen mass is tugging at them. You see, scientists have pieced together quite a cosmic puzzle with us and our visible universe making up just over 4%. Dark matter takes the lead in mystery, accounting for about 23% of everything out there. But then there's this enigmatic dark energy that wraps up an astonishing 72%. We'll dive deeper into it soon enough. Now, let's get back to the detective work on dark matter. One theory was that it could be antimatter, given its unique signature in gamma rays. The problem is, dark matter doesn't produce those gamma rays like antimatter does when it annihilates matter. So, could dark matter actually be black holes? Not exactly. These massive cosmic monsters have a gravitational pull, but their presence isn't as widespread and uniform throughout the universe as scientists believe dark matter to be. Let's kick off our deep dive into dark matter with its fascinating discovery story. What started this cosmic quest was scientists' curiosity about the scale of galaxies, trying to figure out just how massive these celestial bodies are. The challenge: galaxies are humongous and can't be measured like everyday objects. Think trying to weigh a skyscraper by eyeballing it. So astronomers had to get creative. They realized that a galaxy's brightness or luminosity could serve as a proxy to gauge its mass. This was the birth of our journey into dark matter, starting with this innovative approach to understanding galaxy size and mass. So how did scientists stumble upon dark matter's hidden presence? It all began with galactic rotation mysteries. Imagine you're spinning around in a dance circle. The faster you move towards the center, the stronger the gravitational pull should be, right? But here's where it gets weird. When astronomers measured how fast stars orbit within galaxies, they expected to see them zip by at different speeds, slower closer to the center, faster on the edges. Instead, they found something astonishing. Stars near the galaxy's core and those way out on its fringes had identical rotational velocities. This cosmic surprise caught scientists' attention in the 1950s and 60s. But Vera Rubin's groundbreaking work in the 1970s confirmed it. Our galaxies were behaving as if there was unseen mass at play, what we now know as dark matter. Let's dive into this mind-blowing stuff called dark energy. The universe has some pretty wild secrets, and this one's a doozy. Dark energy isn't matter or light. Instead, it's like an invisible force taking up the largest chunk of our cosmos. Yes, you read that right, more than stars, planets, and galaxies combined. Now, here's where things get even stranger. Scientists aren't entirely sure what dark energy is or why it exists. One crazy theory, though: it could be a property of space itself, like an intrinsic aspect of how the universe unfolds over time. This concept challenges our understanding of gravity and space, leaving us with more questions than answers. But isn't that what makes exploring the unknown so thrilling? Let's continue exploring how dark energy affects our universe. Einstein's groundbreaking theory showed us that empty space isn't just an absence of matter or light. Instead, it has a form of energy all its own, known as vacuum energy. This idea laid the groundwork for understanding dark energy as a property of space itself. But here's where things get really fascinating. Did you know our universe is still expanding? It seems to be in this never-ending cycle, with space growing and changing over time. Now, given that dark energy is tied directly to space, it makes sense that its power isn't diluted by the expansion. In fact, as the universe expands, more dark energy is produced, and guess what happens next? That's right, it causes the universe to expand even faster. This exponential growth has some pretty mind-boggling implications for our understanding of time and space itself. The mystery of dark energy continues to baffle us. Even though Einstein's theories provided a groundbreaking starting point, we're still in the dark about what exactly drives its accelerating effect on our universe's expansion. A popular theory suggests that space might be sipping up dark energy from fleeting particles, popping into existence and then vanishing again. This idea is rooted deep in quantum mechanics, which helps us understand how matter behaves at its most fundamental level. But here's the catch: when scientists attempted to crunch the numbers, they found it's hard to figure out just how much energy these temporary particles would actually contribute to empty space. This leaves us with more questions than answers, but hey, that's what makes exploring the unknown so exciting. The plot thickens. Scientists discovered a mind-blowing twist that could be the key to unraveling dark energy's secrets. It might just be an entirely new kind of energy with some serious differences from what we're used to. Imagine if this mysterious force wasn't just another type of energy, but something that works completely against normal energy and matter. This realization is making waves because it raises more questions than answers. What does dark energy look like? How does it interact with our universe's building blocks? And the million-dollar question, why does it even exist in the first place? By questioning Einstein's groundbreaking theory of gravity, we're forced to confront another enigma that challenges our understanding of the cosmos' dark matter. Dark energy's secrets remain locked away, leaving scientists searching for answers that could redefine our understanding of gravity. Einstein's theory still stands strong, but it might need a bit of tweaking. The mystery surrounding this force is a perfect reminder of how much we have yet to discover about our universe. With each unanswered question, we're brought back to just how immense and awe-inspiring the cosmos truly is. So don't forget to drop your thoughts in the comments below if you've got any questions that are keeping you up at night. If magic is more your thing, check out our video on top 10 mind-blowing magic tricks right here. And remember to hit that subscribe button so we can explore the universe together again soon.